Hi everyone, welcome to the new video. Today we will understand what is slicing in Go. Slicing in Go is just an expression for creating slices from other slices or arrays. And to show you how slicing works, let's create an array first. That is, I will name it my array, and then maybe it will hold 10 values. That will be type of integer, and I will give some values to it and then 10. Now let's print out this array to see how. If we run Go, we can see that we have created an array of integer values that has the length of 10. So now let's create a slice using the slicing operator, and now if we just print the slice, we'll see that it holds the same values as the array. To declare a slice from an array or use the slice expression, what you have to do, you have to use brackets and you have to mention the two offsets, that is the starting and the ending position of the array, and separated by a column. So in case that starting and ending position is missing, that means the slice will copy the elements from the array starting from the first element and will end at the last element, in this case 1 and 10. So right now if we mention that is 4 and that is 8, so I guess it will hold 4, 5, 6, 7, 4 values. Starting position will be 4, so in that case will be 5, 6, 7 and 8. So 5, 6, 7, 8 will be the elements that we are copying from my array to slice. So let's run and see whether we are correct or not. Yeah, so this is it. This 5, 6, 7, 8 is the same values that these are 5, 6, 7, 8 within the array. Slicing actually copies not only elements, the memory addresses of the elements as well. So in the slice first element, if we update the value and make it 0, and then if we print the slice and my array, so we'll see the first element of the slice has been updated to 0, from 5 to 0, and the fourth element of the array has been updated to 0 as well. This is because slices uses arrays as the backing store. So whenever you are creating a slice, you are not actually storing all these elements into slice. You are creating an array and you are storing those elements, in our case 5, 6, 7, 8, into that array, and in slice you are storing the information of the pointer of the first element within the slice. So it's actually, the slice holds the memory address of 0, this element, within this array, pointing to that array. And slice also holds the length of the slice and the capacity of the slice. 5, 6, 7, 8 you have copied. So if you update any of the 4 elements, the same values will be updated in the original array as well. So what happens when you are appending an element into the slice? Maybe we will use 100, and now we will print this slice in the my array. Any idea what will happen? So what it is doing, it's appending 100. So you can see right now, instead of 4, this slice holds 5 elements. And interestingly, what it is doing, the value 9, that is the 9th position, is being updated as well into 100. So why is that? So only copied 5, 6, 7, 8, these 4 elements, and then why appending a value into the slice is updating this one? Whenever you are using the slicing expression to create a subslice, the capacity of the slice, capacity means the number of elements a slice can hold, that capacity of the slice is from the starting position to the end of the array or the slice. So right now the capacity of the slice is 5, 6, 7, 8, 9, 10. So that means 1, 2, 3, 4, 5, 6. So if you just use the cap here, and let me just delete this one, you will see the capacity is 6. We have copied 4 values. If we append another value into the slice, this value will also get updated because this is within the capacity as well. So what is capacity in slice? Capacity means the number of elements the slice can hold. So whenever you are creating a slice, suppose you have given the capacity of 100, go creates an array in the memory, reserves a bunch of memory addresses in the memory based on the capacity we have mentioned. And whenever you are adding some values into the slice, maybe appending or mentioning the position of this position of the element, so go put those value into those memory addresses. So initially whenever you are printing the slice, you may not see those memory addresses holding any zero value, like in case of integer zero value is 0, but those memory are reserved for this slice. You can actually use these empty memory addresses to assign values. So in this case, when we created a slice using myArray as a backing store, we not only copied these elements into the slice, we actually mentioned this slice holds all of this. So initially just have copied these 4 values, so that's why slice was showing only 5, 6, 7, 8. So when we appended a value, this value was updated, and as we know that slice holds the length of the slice, so initially the length of the slice was 4, so that's why started from index 0 to index 3, that is 5, 6, 5, 6, 7, 8. As soon as we have appended a value into the slice, the length of the slice got increased. So right now slice knows that it holds 5 values. So where is the 5 value? 5 value is being stored here. So whenever you are creating an array or something, Go reserves adjacent memories and only tracks the initial the pointer of the initial value, the 0 index, and then based on the number of element it holds, it iterates over the adjacent memory addresses to get the required value. Because slice right now slice data structure only knows that it has 4 elements, it is iterating over 4 elements only. As soon as we inform slice that we are appending a value, slice updates its data structure, updates the value stored in the data structure, where the length of the slice got updated from 4 to 5. So whenever next time you are printing the slice know that I have 5 elements, so iterating over 5 adjacent memory addresses. So that's why this complexity. So right now this slicing comes with another offset, that is the capacity limit. So capacity limit generally means that you can use the same value as the end index and or the greater value than this index. You may use 9 in case the capacity will be 5. Initially it was 6 because 9 and 10 was included, but right now whenever you are mentioning 9, means that starting from position 4 to the position 9, this will be the capacity of the slice. If you mention 8, so this means from starting from position 4 to position 8, so this will be the, I suppose I have made a mistake, this is not position 9, this is position 8, because yeah, so slicing the last element, the previous element of the mentioned index will be included into the slice, and this one means that from this position this slice will start copying. So 4 means from position 4, that is 5, and 8 means that is 8th position. So anything before this, I still don't know why this is position 9, 0, 1, 2, 3, 4, 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 10 elements but 9 positions. Yeah, starts from 0. sorry, my mistake. So so this is it. So right now if we print on slice my, now if we just append, now we have mentioned the capacity is 8, the highest capacity is to position 8, that is capacity 4. Now if we do this one, let me just copy this one here and then use it this way. So now what will happen when we are appending this one? So appending a value to the 5th position, but the capacity of the slice is 4. So what Go will do, Go will reserve a bunch of memory addresses where the length of the reserved memory address will be greater than 4, because currently it has 4. It's not sufficient for appending a new value. So maybe 7, 7, 6, 7 or something else we can see in this print statement. And then what will do, it will copy all of those elements like 5, 6, 7, 8, maybe this one 0, 6, 7, 8 from the previous memory address, or in this case from here, from this array's memory address, and then create a new backing array where it will store 0, 6, 7, 8 and then increase the capacity. So then what we'll do, after after this one 8, it will append the value 100 to that memory address and leave other memory addresses as nil. So so that whenever next time you are appending something to the slice, Go doesn't have to copy, like iterate over this process of copying the element, like reserving new bunch of memory addresses and then copying these values into the new memory address and doing everything again. It's just a balance of using memory, like memory and the efficiency, and time efficiency, you can say. So right now if we just go over this and print this one, we'll see that after appending 100, it's get appended here, but you cannot see that value here. So your 9, so 8th position, yeah, the value in the 8th position, that is the value 9, is not being updated. And you can see the capacity of the slice is 8 right now. So initially 4 memory addresses were reserved for this slice. Now 8 memory addresses has been reserved for this slice, and the length of the slice is 100, and starting position of the slice says slice that used to point to this position of this my array is now positioning to a separate backing array. So this is how actually slicing works. And if you want to completely prevent this update, like here you have assigned 0 to slice, first index of slice, so that's why this has become 0, as well as the 5 have become 0 as well. If you want to discard this kind of behavior altogether, what you can do is use the copy function. So what copy function will do, creating a slice from an array or subslice from an array or a slice using the slicing operator, and you don't want to update the original source whenever you are updating the sub slice. So you can do what, you can use the copy inbuilt function. So what copy does is, like, let me just create a empty slice first. This will be an int and the capacity will be 4. So this is a way of creating the slice also. So where this second parameter means the capacity of the slice. So as we will be copying 4 elements, that's why I put the capacity 4. You can put more than the intended length, doesn't matter. So it accepts the destination where you will copy all the elements and the source from where you will copy all the elements. Suppose we will be copying 4 elements from starting from position 4 to position 8. And the interesting thing about copy is that returns how many elements you have copied. Num copied. Now just update the first position like we did here for this subslice. We update the first position. Here also we are updating the first position. Let's put it 1000. And what we can do, let's not do this. First print how many elements have been copied, then the destination, then my array. Let's just remove this white space and run the program. So now see, the capacity of the slice is 4, and that's why it, and the number of elements it has copied from my array is 4, and the updating the first element of destination slice, the first the element in first index becomes 1000, but it does not affect the my array, the original source. So that's how you actually use slicing operators in different ways, and that's what and I have given you some understanding about how slices works and why array not being used extensively in Go still a very powerful feature, because it's being used as a backing store for slice, which is a very useful and commonly used feature of Golang. So that's it for today. Thank you guys for thank you guys for watching the full video, and if you want to support me, please do comment like how like what should be my next topic and about what you want to learn more. Even if I don't acquire that skill, even if I don't have that skill, I will acquire that, and I will I try to make a video where I can make you understand about that concept. Thank you all. Bye. See you in the next video.